Welcome. In this lesson, we're going to be reviewing numerical and graphical limits, as well as drawing limits based on some given criteria. So let's look at estimating a limit numerically. To save some time, I've already put the values in here. Just do this using a calculator. So use a table to estimate numerically the limit. G of x equals the limit as x approaches 0, x divided by the square root of x plus 1 minus 1. Now, of course, our function is undefined when x is 0. If we plug in 0 for x, well, assuming I can draw a 0 here, it will let me, it drew a dot, so it should let me draw a 0. There we go. It just takes a little while. All right, so you can see if we plug in a 0 there, we would end up with the square root of 1, which is 1 minus 1. That's going to be 0 in the denominator. So our function definitely does not exist when x equals 0. All right, so but we have some values on either side of 0. I started off with a low value of negative 0.1, got a little closer, negative 0.01, got a little closer, negative 0.001, and notice that our values are getting closer and closer to the value 2. So we can say the limit as x approaches 0 from the left-hand side, so this is from the left-hand side, is going to be equal to 2. Let's take a look from the right-hand side. So I have the largest value I have is 0.1. Get a little closer with x equals 0.01. Get a little closer with 0.01. So here we are approaching, I'll put the arrow over here. We are approaching 0 from the right here. And notice that, again, our values are getting closer and closer to 2. And if we weren't sure, we could plug in 0.0001, more zeros, right? And our values are going to keep getting closer and closer to 2. So that means the limit of g of x as x approaches 0 from the right is 2. Notice that these two match. The limit as we approach from the left and the limit as we approach from the right are both 2. That means our limit exists. So the limit of g of x as x approaches 0 is equal to 2. And we can note that, and these are all in your notes, that the limit as x approaches 0 of g of x exists this is a symbol for because the limit as x approaches 0 from the left-hand side of our function is equal to the limit of g of x as x approaches 0 from the right-hand side. So since the left-hand and right-hand limits are equal, the limit exists, and in this case our limit is 2. Right? So we can estimate a limit numerically using a table of values filled in the table. All right, so here we have the limit as x approaches as 3 for the function x minus 3. All right, now if I can plug in 3. All right, this function is not undefined when x equals 3. All right, so if I plug that in, this is going to be the square root of 3 minus 3, which is 0. All right, no problem there, and I filled that table in. But how about the limit? Does the limit exist? So first, to determine that, we need to evaluate the limit from the left-hand side and the right-hand side. Let's evaluate from the right-hand side first because it's a little more interesting. All right, so here we are evaluating from the right-hand side. All right, so now the numbers aren't all that interesting. And you're looking at that and you're like, okay, well, I'm not sure what's approaching. But since f of 3 exists, and this is a continuous function, so a square root function is continuous. Actually, all of our radical functions are continuous where they're defined. And our function is definitely defined at 3 and all values greater than 3. So the limit as x approaches 3 from the right-hand side is 0. Right? It is going to head to 0. There's nothing missing. There's no gaps in this particular graph. But what happens if we approach from the left? Well, we have a problem here because if we plug in values less than 3, we're going to have a negative under the radical, and that's not going to be a real number. That's going to be an imaginary number, a complex number. And we are only dealing with the real number system when we're dealing with limits. So here, the limit of square root of x minus 3 as x approaches 3 from the left does not exist. Right? And the limit doesn't exist because the function doesn't exist. So since, and this is in your notes as well, since the f of x equals square root of x minus 3 does not exist for values less than x equals 3. The limit as x approaches 3 from the left does not exist, and the limit as x approaches 3 does not exist. If you don't have a two-sided limit, the limit doesn't exist. So the only limit that exists is, so this is a does not exist, because the left-hand limit doesn't exist. The only one that exists is this one. That one exists. The limit as x approaches 3 from the right, right? So this is a one-sided limit only. So if I asked you if the limit as x approaches 3 of square root of x minus 3 exists, you should say does not exist. We get around that by clarifying where we're talking about with our one-sided limits. So likely if I would ask this question of you, I would clarify that and say as x approaches 3 from the right-hand side, because the right-hand limit does exist here. So we have a one-sided limit, not a two-sided limit. I think this is the last one. That's a numerical, and then we'll look at some graphical. So consider the function f of x equals 1 over x. Find the following limits. Now we're finding limits as x approaches negative infinity, as x grows without bounds, and the limit of f of x as x approaches infinity. Excuse me, the first one was grows without bounds, but in the negative direction, and the second one is grows without bounds. So again, I filled in the table. Our function is undefined at 0, not that that really matters, because we're looking at as x gets very large or very small. So I plugged in some numbers. 10, that's not very large, 100, 1,000, 10,000, 100,000. I could have kept going, but I think we get the idea, right? And then so let's look at the first one. Let's look at the limit of f of x as x approaches negative infinity. So we're going to look to the left here. And we're looking as x grows without bounds in the negative direction. So notice, yes, these numbers are all negative, but notice they're getting smaller, right? Negative, or getting closer to the line x equals 0, excuse me, y equals 0, right? So negative 1 over 100 is closer to the x-axis. 1,000 is even closer to the x-axis. And negative 1 over 10,000 is even closer, and so forth. So notice that as our values are getting, as that x value there is getting larger and larger in the negative direction, or I guess you could say, yeah, larger and larger in the negative direction, notice that the value of the function is getting smaller and smaller. So this is approaching 0. Now let's look to the right. And we see the same thing happening. Right? As I use larger and larger values of x, the whole function gets smaller and smaller and smaller. 1/100,000th is certainly smaller than 1/10,000th. So again, we are approaching 0. So notice here we were looking, finding the limit as x approaches negative infinity or as x approaches infinity. And notice we have to the left for one and to the right for the other. And that's because limits as x approaches positive or negative infinity are always one-sided limits. Can't be more or less than infinite. So those will always be one-sided limits. We're just looking one direction. And just a little preview of things to come. When we have a limit as x approaches positive or negative infinity, where L is a constant, y equals that constant is a horizontal asymptote. So here this function has a horizontal asymptote at y equals 0. And that makes sense, right? Because we know what this function looks like. Right? It basically looks like this. Right? See how well I can draw this. That crossing, oops, other than a little glip there. All right, so that's basically what the function looks like without any numbers on our graph here. Right? And notice as x gets larger or smaller, that our function is approaching 0. So that makes perfect sense with what we know about what this graph of the function, what this particular graph looks like. Right? So we can tie some things from algebra 2 and pre-calculus into limits. Limit existence theorem, also in your notes. I think everything in this video is in your notes. All right, so when does a limit exist? All right, so the limit as x approaches a of some function exists. This means if and only if the limit as x approaches a from the left exists. And this should be review. The limit as x approaches a from the right exists. And the limit as x approaches a from the left equals, oops, I forgot to write the function there. You need to take a limit of something. Can't stand alone. So the limit as x approaches a from the left equals the limit as x approaches a from the right. Right? That's how we know our limit exists. Right? And this is for the two-sided limit. Right? We can have one-sided limits, right? And we saw that in two different cases when we're approaching infinity, when we're approaching negative infinity. Those are always going to be one-sided limits. Also, if our function is not defined, it has an end point, right? And so it stops being defined at a certain point. We're going to only have a one-sided limit, all right? But if we want the two-sided limit, right, our left-hand limit and right-hand limit have to exist, and they both have to be the same. Right? Let's take a look at these ones. All right, so these are in your notes. Let's identify whether or not these limits exist. All right, and we'll find some values of the function. All right, so let's look at A. the limit of f of x as x approaches 2 from the left-hand side. All right, so in this direction here. All right, our one-sided limit technically doesn't exist. We're approaching infinity. All right, so I usually on a one-sided limit will give the direction, and on the two-sided limit put does not exist. You are not wrong, however, to put does not exist, because infinity does not. That is not, you're not approaching something. So for a limit to exist, you have to be approaching a finite number. Oh, you know what, let me put that in there. Let's put one little caveat in here. Not only do they have to be the same, and the limit as x approaches a must be a finite value. Can't forget to say that, right? So approaching infinity from the left-hand side and the right-hand side, all right, that would not count, right? Because technically that's not a limit that exists. So we should be very clear here that when we're talking about a limit existing, it doesn't mean approaching infinity from both sides. It means approaching a finite value from both sides. But technically, infinity is it does not exist. It is perfectly correct to write does not exist. And the limit of f of x as x approaches, that is 2 from the right. All right, so this is 2 from the left, and this is 2 from the right, is again infinity. F of 2, and that is technically it does not exist as well, right, because you're not approaching a finite value. F of 2 does not exist. All right, we have a problem there. There's a vertical asymptote. So I think it's safe to assume that x minus 2 is a factor in the denominator here, creating this vertical asymptote, or something similar to that. Does the limit as x approaches 2 of f of x exist or not? Why or why not? All right, well, we can't say that we're not approaching the same value. Technically are. We're both approaching infinity from the left-hand side and from the right-hand side. But what we can say is that we're not approaching a finite number. All right, so this is a no. The limit does not exist. As the function, and it is labeled with an f, so we can call it f of x. As f of x does not approach, we're missing an O. A finite value, whoops, all right, I did not touch that. I did not touch that. I am way far away from the keyboard. Does not approach a finite value as x approaches 2. So that is a no. All right, let's find this one. The limit as x approaches 2 from the left. All right, so here we are approaching from the left-hand side, and our function is approaching 2. The limit of f of x as x approaches 2 from the right. I probably should put a little arrow here. So here we're approaching from the right. And again, we are approaching the value 2. F of 2, however, does not, f of 2 does exist, but it is not 2. It is negative 3. So f of 2 is equal to negative 3. Does the limit as x approaches 2 exist? Why or why not? This one is a yes. All right, we've got the limit as x approaches 2, and this is again labeled an f of x. The limit as x approaches 2 from the left exists. The limit as x approaches 2 from the right exists, and these limits are the same. Now, on the other page with the limit existence theorem, where we clarified that it had to approach a finite number, that was just to make it clear that example 1 is not a limit that exists. By saying that the limit exists, it means you are approaching a finite value, right? Your limit can't exist if you are approaching negative infinity, infinity. That's not a limit. All right, so we do not have to clarify on number 2 that it has to approach a finite value. We took care of that when we said the limit exists. All right, so on the other page, that was just to clarify for everyone that 1 is not an example of a limit that exists, but 2 is an example of the limit that exists. It does not matter what f of 2 is. Right? The function doesn't even have to be defined at that value. All that matters is that as we get closer from the left-hand side and the right-hand side to x equals 2, that we are approaching the same finite value, and we are. All right, so now let's take a look at the third one. Find each value of the function of the following from the graph. The limit as x approaches 2 from the left. So we are heading this way. Right, and we are approaching 3. So this is 2 from the left, and that was 3. The limit as x approaches 2 from the right. That would be going this way. Right? We're coming from the right here. And that is negative 3. F of 2. Right? So f of 2, you can see the dot filled in there, is 3. Same as the limit from the left-hand side. Does the limit as x approaches 2 of f of x exist or not? This one is a no. Since the limit as x approaches 2 from the left, do I have enough space? I may have to extend the board, and I can't see the extended board, the extended page. It's on the easel for some reason. So since the limit as x approaches 2 from the left of f of x does not equal the limit as x approaches 2 from the right, the limit of f of x as x approaches 2 does not exist. Right? So this is not a limit that exists because the left-hand side and the right-hand side are not the same limit. You can see that we have an issue here. We have a jump discontinuity. So notice that we have 3 different types of discontinuities here. In the first example, we have what's known as a vertical discontinuity. And you should label this. Right, that is never going to be a limit that exists when you have a vertical discontinuity. In the second example, we have what's known as a point discontinuity. And what's interesting about the point discontinuity is this is called a removable discontinuity. Now, in this case, and we do have a little issue there because we already have a point, and it'll cease to be a function if I fill this in. But technically, point discontinuities are removable discontinuities because if we filled in the point, we would cease to have a discontinuity. With the vertical discontinuity, can't do a thing about that one. And the last one is known as a jump discontinuity. There is literally a jump in the graph, right? We jump from one piece to the other piece. All right. So here's a little look at different types of discontinuities. Point discontinuity, the limit's still going to exist. Vertical and jump, no. sketch a graph. Oh, and you know what? Let's take a break, and I'll start this problem on the next video. All right, at 25 minutes, I think it's time for a break. Thanks for watching. Bye for now.